Okay, in this video we are going to solve the 2005 AP Calculus AB free response question. So it gives you dy over dx equals negative 2x over y. And it says on the axis provided, sketch a slope field for the given differential equation at the 12 points indicated. So when you start this, I guess you could start with negative 1, comma 2. This is x, this is y, so now we need the slope. So if you plug it in, you're going to get 2 over 2, which is 1. The slope over here needs to be 1. So you're going to draw a slope of 1. Make sure it has the right steepness. So now we're going to do one more of these, negative 1, 1. When you plug this in, you're going to get 2 over 1, so your slope is going to be 2. It's going to be steeper. So make sure it has the right steepness, which I believe it looks like this. And the last one I'm going to do before I pause this video is, if you do negative 1, negative 1, you can't do anything with 0 because there's no slope there. So that means you're going to have range issues. It's probably a square root or an ln function. I believe it's probably going to be square root. So if you plug this in, you're going to get 2 over 1. You're going to get negative 2, negative 1. I'm sorry. You're going to get a slope of negative 2. So make sure it has the right steepness. Okay, I'm going to pause the video now while I fill in the rest. Okay, the next part of the question says, part B says, let y equal f of x to be the particular solution for a differential equation with the initial condition 1 comma negative 1. Write an equation for the line tangent of the graph of f at 1 comma negative 1 and use it to approximate 1.1. Okay, so two things that you need. You need a point and a slope. You have the point. The point is 1 comma negative 1. If you want the slope, you do dy over dx equals negative 2 times 1 over negative 1. So now you're going to get a slope of 2. So now when you write your equation, y plus 1 equals 2 quantity x minus 1, y equals 2x minus 2 minus 1, y equals 2x minus 3. Now we're going to plug in the 1.1 so we can approximate. So y of 1.1 equals 2 times 1.1 minus 3. So now you're going to get 2.2 minus 3, and it's going to equal 0.8, negative 0.8. Okay, the last part of the question says, find a particular solution to y equals f of x to the given differential equation with the initial conditions 1 comma negative 1. So now what we're going to have to do over here is we're going to have to separate the variables. So when you separate the variables, you're now going to write dy over dx equals negative 2x over y. This is part C. So you're going to get y dy equals negative 2x dx. Now you're going to integrate both sides. So now you're going to get y squared over 2 equals negative x squared plus c. Now we're going to plug in our conditions so we could solve. So now we're going to get y 1/2 equals negative 1. It's still going to be negative because of that negative outside, plus c. So c equals 3/2. You're now going to plug in the 3/2, and now you're going to get y squared over 2 equals negative x squared plus 3/2. You're going to multiply both sides by 2. So when you multiply both sides by 2, you're now going to get y squared equals negative x squared plus 3 take the root of both sides. So now you get y equals the root of negative x squared plus 3. But if you just leave it like this, then you're saying it belongs up here, like if you had a graph above the y-axis. But the initial point that you're doing is 1 comma negative 1, so it's over here. So when you do this, it's going to look like this. Well, let me draw it better. Like this. So this has to be a negative because it's the range. It's a square root function. And remember, the root of 4 is 2 or negative 2. In this case, you want the negative part of the equation. I hope this video helped.